There is a quantity in this universe that never changes. Energy. Energy is defined as the ability to do work. Energy exists in many different forms: magnetic, kinetic, heat, light, chemical, nuclear, potential. In mechanical engineering, we are particularly interested in mechanical energy. Mechanical energy is made up of kinetic energy and potential energy. Kinetic energy is the energy associated with the motion of an object. The word kinetic comes from the Greek word kinesi, meaning motion. Potential energy is energy associated with changing the position of an object. But what do we mean by this? An example of potential energy is gravitational potential energy. When we lift up a weight to a height, it takes physical effort. This is because we are increasing the weight's potential energy. The amount of effort required to lift the weight depends on how heavy the weight is and how high it is lifted. Knowing this, we can create an equation for gravitational potential energy. GPE equals weight times height. Using this equation, we can calculate that a weight of 100 newtons at a height of 3 meters has the same potential energy as a 300 newton weight at 1 meter. The unit used for energy is called a joule, and we use the symbol J. Consider this pendulum. Notice how its maximum height is always the same. We know that at this position, the potential energy is its height multiplied by weight. As we decrease the height, we decrease the potential energy. At the point where the pendulum is at its lowest, it has no potential energy. And then, as the pendulum swings about, the potential increases, until it reaches its maximum height, at which point it has the same potential energy as it started. We can see the potential energy increases and decreases as the pendulum swings, and as we have said, the overall amount of energy cannot be changed. So where does it go? If we track the motion of the pendulum, we see that at maximum height, the pendulum is stationary. As the pendulum swings downwards, its speed increases. At the minimum height, the pendulum has maximum speed. As the pendulum increases in height, and its speed decreases. As the pendulum reaches maximum height, its speed is once again 0. So it can be seen that as the height decreases, the motion increases. All of the potential energy is converted to motion energy, which is called kinetic energy. And then as the pendulum rises, the kinetic energy is converted to potential energy. At all points, the total energy is the same. Energy simply changes from one form to another, but never increases nor decreases. To compare kinetic energy to potential energy, we use the equation half mass times speed squared. We can equate these equations to solve problems, such as this one. What is a pendulum's maximum speed? Let's say our height is 3 meters at the start, and the pendulum has a mass of 10 kilograms, and we let go. The maximum velocity occurs at the point when all the potential is converted to kinetic. This is when the height is equal to 0. We can apply these values to the potential energy equation, and then we can say this is equal to the kinetic energy. We then rearrange to find the speed. However, we all know that pendulums eventually stop swinging. So why is this? As the pendulum swings, the pendulum's kinetic energy is transferred to the molecules that make up air. This means that the pendulum is losing energy, and so eventually it comes to a stop. We can see examples of energy conservation in real life every day. A child on a swing is converting potential energy to kinetic energy. When an archer draws their bow, they are transferring kinetic energy of their aim to a potential energy called elastic potential energy. This potential energy is stored in the bow. When the archer releases the bow, all of the potential energy converts to kinetic energy in the arrow, casting the arrow to fly. We can also see energy being conserved on roller coasters. The train is dropped from up high and then increases in speed as it falls. Gravitational potential energy is converted to kinetic energy. If the train rises again, say in a loop, the speed will reduce as potential increases. In mechanical engineering, we use conservation of energy all the time. It is one of the most useful physical laws and applies to every situation we come across. A good example is the design of a hydroelectric dam. A hydroelectric dam works by having water in a reservoir. Some of this water is taken from the reservoir and falls down to a turbine. So we start with potential energy of the water, and as it falls, this converts to kinetic energy, and then the water's kinetic energy transfers to kinetic energy in the turbine, which we can then use to generate electricity. By using conservation of energy, we can calculate exactly how much energy we can generate and design the dam in order to get a maximum efficiency. In engineering, we are very interested in energy transfer. This allows us to calculate and design systems such as engines, nuclear power stations, and rockets.